This conference will now be recorded.
In yesterday's session, we were discussing about application load balancer. What is application load balancer? And in application load balancer, we have some advanced routing rules which we can define here. There is a concept called listeners. In the listeners, we are going to define the port and the protocol on which the load balancer should accept the request. Then in this listener, we can define the routing, application application routing. So this supports path-based routing. It supports host-based routing based on the request, right? As I already told, this is layer 7 load balancer. It works at the request level where we can define the routing at the application layer based on the host, based on the path. We were able to define the routing at the this listener. If you see, we have only one load balancer, that is one application load balancer which we created yesterday in the load balancer section. So there is one application load balancer which I created yesterday. I'm talking about this one, this demo ALB, and this load balancer has a listener. This is accepting the traffic and it is forwarding the request based on the rules. Here we have added some rules in this. We have added some rules in this listener. We have added path-based routing. So same load balancer, same load balancer, same load balancer, but based on the path, based on the path, we are getting the request to this load balancer. It is forwarding the request to different target group. Load balancer has a listener, and load balancer comes with the DNS name. This load balancer has a DNS name. So we are using this DNS name to route the traffic based on the request path. Request is going to the respective load balancer. You can see when we access like this, request is going to one target group where one application is running, and another request is going to another target group where other application is running. Are you guys able to set up an application load balancer like this? Are you guys able to practice all these things, whatever has been discussed? Give me 1 minute, guys. Are you guys able to practice whatever has been discussed? Are you just listening only in a listening mode from day one? Guys, if you manually create all these things, it will become easy for you to understand subsequent concepts. Anyone completed so far whatever has been discussed? EC2, EBS, S3, load balancing, VPC. Come on, guys. Am I audible or I am speaking myself? Guys, without practicing, you will not get that feel. Whatever topics you guys are listening, without practicing, you don't get that feel, right? If you just attend for the sake of attending, you may remember for some time, but practice is very, very important. Make some time, right? Make some time and practice so that you can understand what you are doing. Okay, anyhow, when you guys are practicing, if you face issues, you can let me know, or you can revise the recording one more time, or you can let me know in the Skype group so that I can assist you. But without practicing, if you just attend also, that may not help you. Now, let's come back to one more topic. As I already told yesterday, load balancer is performing the health check. Load balancer is performing the health check to check the health on the application to shift the traffic away from that failure instance. Yesterday also I have clearly told. So load balancer is performing the health checks on the given targets in the target group. If any of the target becomes unhealthy, load balancer will stop sending the request to that unhealthy server. But is it going to recreate that unhealthy server? Is it going to terminate that unhealthy server and create a new server by that ELB? No. So at any point of time, I need some minimum servers. At any point of time, I need some minimum servers. If one of the server goes down or unavailable or unhealthy, that failure server has to be replaced with another server. If there is a lot of load, there should be automatically increasing and decreasing the servers. Scale in, scale out should happen. So that is where you have an auto scaling group. So yesterday, theoretically, I have explained at high level what is auto scaling group. So in auto scaling group, we have some components. In auto scaling group, we have some components. What are the auto scaling group components? We have something called launch configuration or launch template, we call it. Launch configuration or launch template. Launch template. Launch template. And we have a scaling policies. Scaling policies. So we can create EC2 instances, and those EC2 instances using auto scaling group. Using auto scaling group, we can create EC2 instances, and those life cycle, those EC2 instances are managed by ASG auto scaling group. Its life cycle, basically, its life cycle is being managed by auto scaling group. So while creating auto scaling group, while creating auto scaling group ASG in the short form, we can specify the group size, auto scaling group size, like minimum servers, maximum servers, and optionally desired number of servers, right? Optionally desired number of servers. So auto scaling will make sure always minimum servers are available, always minimum EC2 instances are available. Auto scaling will always make sure the minimum servers are available. We already discussed the advantages also yesterday. So EC2 instances are managed by auto scaling groups. Create auto scaling group by defining minimum, maximum, and optionally the desired number of EC2 instances. So auto scaling group use launch configuration to launch EC2 instances. As I told yesterday, what type of EC2 instance has to be created, what AMI has to be used, what security group needs to be attached, what IAM role, if required, in case any IAM role has to be used for that server, to grant permissions to other AWS resources. And again, SSH key pair, user data, all those things you can define using launch configuration or launch template. So that launch template is an input for creating servers by that auto scaling group. Auto scaling will keep always minimum number of instances running. It will launch or terminate the instances to meet the desired capacity. It will never start more than maximum number of instances, and it will keep the capacity balanced across availability zones in that region. As I told, we can create auto scaling group by defining minimum size. Here I am just giving minimum like this, but this can be 5, this can be 10, like this, as per your application requirement. This can be 5, this can be 10. and optionally desired. So at any point of time, if I give minimum as 5, 5 servers will be there. If any server goes down or if any server becomes unhealthy, that auto scaling will perform the health on the EC2 instances. If auto scaling detects that instance is unhealthy, what auto scaling does? Very, very important service. That's why again I am explaining, which is widely used service in AWS cloud or any other cloud. That's why we are again discussing this theoretically before I go for a lab. So if auto scaling detects that the instance is unhealthy, which is created by that auto scaling, that instance is unhealthy, what auto scaling group does? It will terminate that EC2 instance. It will terminate that EC2 instance. Terminate in the sense delete. It will terminate in the sense delete. It will delete that EC2 instance and it will create a new EC2 instance to replace the failed one. And whenever there is a load, I should be able to scale my servers up to the max size I can scale. But when that scaling will happen, the scaling will happen automatically? No. So you need to define when to scale and how to scale based on the scaling policies. So scaling policies will update the desired capacity. The scaling plan tells how auto scaling, when to scale and how to scale. Create a scaling plan based on the occurrence of the conditions. So there are some types of scaling plans. Someone should update this desired capacity. Let's say if someone update the desired capacity as 6 and currently there are only 5 instances and desired is 6. So what auto scaling does, it will match the desired number of instances with current number of instances for that auto scaling group. So if someone should update this desired capacity, that is where the scaling policies comes into picture. We have different types of scaling policies. One is manual scaling, manual scaling, this scheduled scaling, and there is something called dynamic scaling or auto scaling. Dynamic scaling. So manual in the sense using GUI or CLI or any running APIs also manually. We can update the group size or desired size, basically the update the desired instances manually by using console or by using CLI. Scheduled based on time events, based on time events. So and so date, so and so time I should have these many servers, like that. And the dynamic based on the metrics, based on the metrics, based on the system metrics, based on the EC2 metrics like CPU utilization, based on the CPU utilization on those servers, based on the network in and out statistics, based on application request count per target by that target group, like that. So based on some metrics, we can create a dynamic scaling policies. So whenever that threshold value is matched, right, auto scaling will trigger the scaling. That event will trigger the scaling. So auto scaling is widely used in cloud AWS, right? Sometimes in the interview they are asking one question: what is the services, what are the services which you can use to achieve high availability, scalability, elasticity, fault tolerance in your applications which you are going to deploy in your AWS cloud? So what are the services which we can leverage in the sense which we can use to achieve high availability, fault tolerance, scalability in the applications which we are going to deploy on AWS cloud? What services? We can use ELB with auto scaling, combination of ELB with auto scaling group. So is everyone clear? Internally, this dynamic scaling policies will use CloudWatch metrics, CloudWatch alarms. So CloudWatch is one monitoring service in AWS. So CloudWatch will monitor your EC2 instances. It will gather the system metrics. So based on that metrics, the alarms will be created in CloudWatch. That CloudWatch alarms will be internally used in the dynamic scaling policies. Whenever that condition is satisfied, an event will be triggered in auto scaling group to update the desired servers. Is everyone clear theoretically what is auto scaling group? Why do we need auto scaling group? What are the components of auto scaling? How it works? Before I go for a lab using GUI. Auto scaling group can be used. Auto scaling group can be used for any type of workloads. Suppose you guys are using virtualized deployments. I hope you can understand what do you mean by virtualized deployments. Directly you are running your applications or softwares directly on the virtual machines, not as a containers. So I can create a auto scaling group for my virtualized deployments for my applications. Or if you guys are using containerized deployments, like you are building and running your applications as a containers, container images, you created a container image with required softwares and configurations plus your application code. You can run your applications as a containers using container runtime, like a docker containerd, like that. So if you guys are using containerized workloads, containerized applications you want to deploy in real time, you are going to use Docker Swarm clusters or Kubernetes clusters. So in case you can manage your Docker Swarm nodes or Kubernetes nodes also. That EKS node group is also one kind of auto scaling group. So you are just going to create an auto scaling group internally. That auto scaling group will create a worker nodes for your EKS cluster, and those nodes will join to the cluster. But you no need to deploy the container images into that nodes via auto scaling. The Kubernetes can schedule the applications, that containers into your EKS cluster. But if you guys are following virtualized deployment, do I need to automate the deployment of my application also? Not only just installing required softwares like Java and Tomcat, I need to automate the process of deploying the applications also using auto scaling group only. Because if it is just creating a server without application, that server will not be any way helpful. So if you guys are using virtualized deployments also, you can use auto scaling groups. If you guys are using containerized deployment, your EKS node group is nothing but one auto scaling group in the background. Clear? Any confusions, any queries, any questions? Before I demonstrate auto scaling group for this application, I am going to demonstrate auto scaling group for this application. So it's a virtualized deployment. We deployed this application directly in the VM. Now if something goes wrong with that VM, that virtual machine, there is no another virtual machine available for these applications. So my load balancer will stop sending the request to that failed server, and there is no other server which is getting created. I'll demonstrate auto scaling group for this application in a virtualized way. Any question, any queries, feel free to ask, because this is very important service. I'm considering your silence as no. You don't have any question. Let's get into the lab. Now, as I already told in yesterday's session, these servers are not managed by auto scaling group. These servers are not managed by auto scaling group. If something goes wrong with this server, you will not get another server, right? I already shown yesterday also. Let's say this server, let me intentionally make some changes in this server. Let me intentionally stop the Tomcat on that server. So load balancer will just I can't directly SSH to the private server. So let me SSH to the public server. From there I'll SSH. If something becomes unhealthy, load balancer will stop sending the request to that server. Load balancer will stop sending the request to that server. If you see, now from here, let me access to that private server. Let me intentionally stop the application, that Tomcat in that server, one of the server, which is healthy as of now. But let me intentionally stop Tomcat in this private server by SSHing. Now load balancer will just perform the health check and it will mark that instance as unhealthy. If you go to this target group which is used, right, after some time as per your health check settings it will become unhealthy. So it is going to perform health checks based on this data, right? Every 10 seconds request will go to the target group on the target group path, target port on this path. If it is not getting 200 continuously two times, it will consider that as unhealthy. Now you can see already this node become unhealthy. The load balancer will stop sending the request to that server, whatever server which is unhealthy, right? But it is not going to be deleted and recreated. Now I can make that possible using auto scaling group. So let me create a auto scaling group. Let me create a auto scaling group. So here you have one more service in EC2 dashboard only. You can see there is something called auto scaling group. In EC2 dashboard, there is something called auto scaling group. So if you see, I already have for other batch, for one of the regular DevOps batch, I created one EKS cluster. I created one EKS cluster. For that EKS cluster, I added one node group. For that EKS cluster, I added one node group. I have one EKS cluster. For regular DevOps batch, I created this one. And this EKS cluster has one node group. One node group. You can see this node group. So the node group is basically internally, it is one auto scaling group only. This node group is internally one auto scaling group. This node group, whatever you have added to the Kubernetes cluster, the EKS cluster, this is internally one auto scaling group. So internally it has created one auto scaling group to manage the Kubernetes nodes, that worker nodes. And you no need to create a launch configuration again for EKS nodes. So it is very complex user data you need to write. So Kubernetes, that AWS itself will internally create a launch configuration, and this auto scaling group is created using this launch configuration. This launch configuration is created by AWS only, not by us for EKS. So this launch configuration or launch template has a details what type of AMI has to be used for creating that EKS nodes, what type of instance type, what security group, how much storage, and in the advanced details they only have some kind of a user data. They only have some kind of a user data where they are installing required Kubernetes softwares and they are joining the required they are joining that nodes to that Kubernetes cluster like that. So now similarly, I can create a auto scaling group for my own application requirements also. Even though you are not going with containerized deployment like Kubernetes, you can create auto scaling group and its launch configurations for any of your use case. For now, let me create a auto scaling group and its launch configuration for this application directly, virtualized deployment. Let me go to auto scaling groups. You can create a launch configurations or launch template. Launch configuration is the old way of creating a information. But is Kubernetes, AWS introduced something called launch template. I can create a launch template. So using launch template, as I already told, using launch template or launch configuration, you can provide information about AMI, what AMI has to be used, what instance type has to be used, and what security group, what SSH key pair, right? And again, how much storage, any IAM role if you have to attach, and you advanced details, that user data, if any, in case if you want to execute user data, right? User data. So here you are just going to provide this information. You no need to provide VPC subnets. These VPC and subnets you are going to provide when you are creating a auto scaling group. Under which VPC, under which subnet, that auto scaling group has to create a servers. That when you are creating auto scaling group, that time you will specify the VPC subnets details. So here only AMI, instance type, all these informations you are going to provide. VPC details you are not going to provide here. VPC details you are going to provide when you are creating auto scaling group using this launch template, in which VPC, in which subnet that auto scaling has to create a service that you will provide when you provide a auto scaling group. Now, if I take a plain Red Hat AMI, now I can create a launch template for my requirement. I can create a launch template for my requirement. But if I select just a community AMI like this Red Hat AMI, will I get a required softwares into the EC2 instances created by auto scaling group? No. So there are various ways you can do. One way, as I told, you need to write some kind of a user data. User data you can provide user data in the sense bootstrapping script. You can write a bootstrapping script in whatever way you want to do. Otherwise, you can have a golden image also. Golden image. What do you mean by golden image? Your own AMI. Your own AMI. That AMI can be created from existing EC2 instances also. Or you can create a AMI using Packer. So with required softwares and configurations, you can create a AMI. If that AMI itself already has a required softwares and configuration, do I need to write complex user data, or do I need to do some installation and configuration again in the EC2 instance? No. So to make things simple here, I will not select this Red Hat AMI. First, I'll create my own AMI. I'll create my own AMI. I already have one server. I already have one server in which in which I already installed Tomcat, in which I already installed Java, in which I already have a WAR file also, because it's a virtualized deployment. I already installed Java directly in that system. I already installed Tomcat directly in that system, and I have that WAR file also deployed in that system. I'll create a AMI out of this server. This server. For that application, I'll create a AMI out of this server. You go to actions, image, create image. So I'm saying my, let's say Maven web app AMI like that. So this AMI, I'm creating a AMI from existing EC2 instance so that I no need to do lot of configurations and installation if I use this AMI, right? So now AMI is getting created, that I can consider as a my AMI or golden image. That I can consider as a my AMI or golden image. This I can consider as a my own image. Now this AMI is created from EC2 instance. That EC2 already has a Java, Tomcat, and your code also. Now if I create a server using this AMI, whether I am manually creating using this AMI or my auto scaling group is creating out of this AMI, will I have a Java, Tomcat plus that WAR file also into the EC2 instances created out of this AMI? Yes. So I will use this AMI in my launch template. I will use this AMI in my launch template. So is everyone clear what I have done here? You can take a community AMI also. You can take community AMI also, but you need to write some kind of a user data where you need to install required softwares, configurations by running some scripts, some commands. If required, you can deploy your applications also if you are using virtualized deployment. But if you guys are using containerized deployments like Kubernetes or Docker Swarm, you no need to deploy your containers. You just create a nodes with Kubernetes software and make sure that Kubernetes node joined to your Kubernetes master. Once the node is joined to the master, does your master can schedule the pods into the Kubernetes nodes? Yes. So you just make sure nodes are created and nodes are joined to the cluster. But here I am following a virtualized deployment. So I am just creating a server with required software plus code also, my application package also. So this AMI has everything. So let me create a launch template. Here you can use this launch templates under instances. You can see launch templates. So this launch template was internally created by Kubernetes, that AWS only for EKS. Let's leave this. I'm creating my own launch template for other application, other use case. Create launch template. I'm creating a launch template. Something like this I'm giving. Maven web app. launch template. Now here you don't no need to give this template tag, source template, leave this AMI. Now instead of selecting this quick start using this community AMI, I'll select my own AMI. Just now I created AMI, right? This Maven web app AMI out of that EC2 instance. So I select this AMI, my AMI. Then what type of instance? If this launch template is used in auto scaling group, that auto scaling group has to create what type of instance using this AMI, what type of instance it has to create. As per my requirement, I can select anything. For now, I am selecting t2.micro. I am selecting t2.micro. Now, what key pair? In case if you want to SSH to that EC2 instances created and managed by auto scaling group, what SSH key pair you have to use? This key pair. And here you no need to specify the network. Don't select any subnets here. This I will select when I create a auto scaling group. Don't select any subnets here. This we will select when we create a auto scaling group. But you need to select the security group. What security group has to be used with that servers when auto scaling create that server? What should be the security group it has to attach? So here you can select existing security group, whatever you have in that VPC. Otherwise, you can create a new security group also. So since I'm going to install Tomcat and the Tomcat will be running in that server, do I need to open the Tomcat port so that my load balancer can reach that instance? Yes. So let me create some new security group. I'll say something like this. I'm giving security group, and I am going to allow, maybe I'll allow SSH also. Just a description I'm giving. Now the security groups are network specific, VPC specific. Since I'm planning to use this launch template with the demo VPC, make sure you are creating that security group also in the demo VPC. And let me add the inbound rules. Select demo VPC. Let me add the inbound rules where I will allow port 22 in case if I want to SSH, and also port 8080 for making my application accessible via load balancer. So these two ports I am opening and I am creating a security group, and it will use that security group. And the storage, how much storage? By default it is attaching 10 GB. If required you can make 20 GB, 30 GB also, it's up to you. Now still you need to give some user data. Why? Because even though I am using my own AMI where I have a Java software already, Tomcat software already, where file is also there, but I don't have a service file for Tomcat to start on the startup. Whenever the server is started, Tomcat will not be started automatically because I have not created a service file and I have not enabled the Tomcat service on Bootstrap in the existing EC2 instance. So even though you have a Java, even though you have a Tomcat, that application code also, does Tomcat process will be started automatically if I use that AMI? No. So I can make that happen via user data. User data, first and foremost thing you need to understand, you need to give a shebang line. You need to give a shebang line. So make sure you are giving a shebang line. You know in Linux, right? Shebang line. So you need to give the shebang line. Then you can provide the script. So what is shebang line? You already know, right? So you are going to give shebang line bin/bash or sh, whatever shell you want to use. Then what command? As I already told in the beginning only, I already told in the EC2 only, user data will be executed as a which user. You no need to give sudo also, as a which user data will be executed. Did you guys remember EC2 sessions? Root user. So let me, no need to use sudo. So let me do something. Sometimes we have some permissions problem. Sometimes we have some permissions problem. So that's why I am giving something like this recursively on the Tomcat 8 folder, opt/tomcat 8 folder. Then I will do something like this. This is where I have Tomcat installed already, right? Then guys, your script has to be proper. Then what I am trying to do, right? sh bin slash something like this, or you can give something like this also slash bin. Then you can directly say sh startup dot sh. This is what the script you have, right, in that Tomcat bin to start the Tomcat. You know all these things. Now this is my user data. Okay, guys, as I already told, if you guys are doing some kind of installation, but that installation I have already done. If you guys are doing some installation, you should not give any, you should not wait for any user feedback. If you just give like this, it won't work, because it will wait for user feedback, user input, right? Whether you want to install or not, that YRN option will come. So we already told all these things, right? If you while doing something, you need to give something like this if you have to do. But anyhow, this we already discussed. I am just giving a startup script here. This is my user data. Using this, I am creating a launch template. But is EC2 instances will be created now if I create a launch template? No. So let's create only launch template. This launch template I will use with auto scaling group. This launch template I will use with auto scaling group. You can directly create a server using that launch template, or you can use that launch template to create an auto scaling group. Now let me go back to EC2. Let me go to auto scaling group. I'll create one auto scaling group for that use case, for that application. Create auto scaling group. I'm giving a name, Maven Web App ASG auto scaling group, like that. I'm giving some auto scaling group name like this. And as I already told, the input for auto scaling group is launch template or launch configuration. But I created a launch template. I'll select this launch template, whatever I just created. So Maven Web App, that launch template. And leave about these versions because we have only one version. Click on next. Click on next. Now you select the VPC. In which VPC that auto scaling group has to create and manage your EC2 instances. So I'll select the demo VPC, whatever VPC, in whatever VPC I want to create, I will select this demo VPC. Now this is for your EC2 instances, for your application servers. I am going to select only private subnets because I don't want to place those application servers in a public subnet. Let me select only private subnet, these two subnets. Now auto scaling group will create a EC2 instances in this network, in these subnets, in these two availability zone. Click on next. Here you have an option to integrate auto scaling group with load balancer. Here you have an option to integrate auto scaling group with load balancer. So they're giving this option: no load balancer, attached to an existing load balancer, or if required you can create a new load balancer while creating auto scaling group and attach those servers to the new target group also. But I already have a load balancer. I already have a target group which is used in that load balancer. So let me select this option and I'll select the target group. So I'll select this target group. I'll select this target group, ELB demo, this target group, which is already used in this load balancer. We already have a load balancer, right? Let me show that. Yesterday we created a load balancer. If you guys remember, we created one load balancer yesterday, this one. This one. In this load balancer, we already used the target group, right? In this load balancer, in this listener, we already use the target group. So instead of you manually register the targets to this target group, that auto scaling group only will register those those servers to the target group. So that is what the meaning of this one. So I select attach an existing load balancer and I select this target group. So you no need to manually register whenever any EC2 instances are created by auto scaling. You no need to manually register into the target group. This target group is already there and you are integrating. So load balancer will forward the request to the target group, and if the auto scaling is added the servers to this target group, load balancer will forward the request to this target group also, this targets also. Now auto scaling also perform the health checks. Auto scaling also perform the health checks. It is going to, by default, it is going to perform EC2 health checks. If it is only performing EC2 health checks, it will just check whether instance is in running state or not. But it will not check whether that application which is running in that EC2 instance is healthy or not. Even though instance is running, let's consider the Tomcat is down or your application is not responding. Does auto scaling will consider that EC2 instance as unhealthy instance if instance is running but application is not running? No. So since we are already integrating with load balancer is performing the health checks. So if I select this ELB health checks also, whenever load balancer marks that instance as unhealthy, auto scaling will terminate that EC2 instance and create another EC2 instance. If ELB is internally performing the health check, and anytime if ELB mark that instance as unhealthy based on the ELB health checks, this auto scaling will terminate that server and it will create a new server. So is everyone clear? What do you mean by this ELB health check? Why we are selecting this one also here? Now health check grace period. So by default it is showing 300 seconds. So the amount of time until EC2 auto scaling wait to perform the first health check. The amount of time EC2 auto scaling performs the first health check. So the moment EC2 instances is created by auto scaling of, and if it is performing the health check immediately, your server might not be fully ready. Your application might not be fully ready. So if it is starting the health check immediately, the moment it is created the server, do you think health checks become successful? No, right? Because it will take some time to boot the OS, it will take some time to start the applications or process. So it should not perform the first health check immediately. So how many seconds it will wait to perform the first health check? That is what the meaning of health check grace period. So by default they have 300 seconds, which means 5 minutes. So the first health check will be performed after 5 minutes when that EC2 instance is created and put into the service. But after first health check, it will perform immediately. So based on your requirement, you can modify this one also. Is everyone clear? What is this health check grace period? Now, if required, we can enable metrics also with CloudWatch. CloudWatch will gather the metrics from these EC2 instances. I am disabling as of now, but still EC2 will, CloudWatch will gather the metrics. For now, I am not selecting anything here. Let me click on next. Now this is where we are defining the group size, minimum size, maximum size. For demo purpose, I am defining minimum to maximum 5 like that. But does this can be any number as per your requirement at any point of time? If you need maybe 10 servers, can I say minimum as 10? Can I say minimum as 20? Based on your application requirement, based on how much traffic you are expecting for that application? Yes. So for demo purpose, I'm just defining minimum as 2, maximum as 5. So at any point of time, you make sure this desired also 2 initially. Make sure you define decide also to initially. So at any point of time, how many servers will be there, irrespective whether you have a load, whether you don't have a load. For that auto scaling group, 2. So when there is a lot of load, when there is a lot of load and there is a policies, there is a dynamic scaling policies. When there is a lot of load and there is a dynamic scaling policies, based on the metrics, it can scale up to how many servers? Up to 5. But even after having 5 servers, if there is still lot of load, even though CloudWatch is triggering the alarms, do you think it will go beyond that max size? Does the desired capacity will go above max capacity? No. So this is just a group size. Now you are just creating a auto scaling group, but without a dynamic scaling policies. Without dynamic scaling policies, if you go with this option, none option, without dynamic scaling policy, even though you have a load like very high CPU utilization or something, are you going to get a third server, fourth server automatically without scaling policies? No. So I will create a policy. I'll create a policy. I'll create a policy. Minimum, can you give 0? Yes, you give minimum 0 and desired 0. Then what is the use? What is the use? Minimum 0 in the sense, do you have any servers? For your auto scaling group, auto scaling group will be there. Auto scaling group will be there. But for that group, do you have any servers? If you give minimum 0 like that, you don't have any server, that is of no use. Okay, you can give, it is not allowed. Understand, it is plain English only. Minimum 0, you are expecting 2. Is it correct? In plain English, you no need to be a scientist, a computer specialist. You are saying desired, I need 2, but minimum 0. It will throw right away error. You click on next, right? You try to create auto scaling group, it will say error, right? It is not going to be allowed. That is of no use, right? Minimum 0. So when there is low load, when there is no load, let's say, I think I have, let's say I close this one. Let's say desired is 2, minimum 0. Let's say you have a policies, a scaling policies. If there is no load, will it make 0 that desired? Now you are setting desired as 2 and you have a scaling policies. Let's say there is no load. Does the desired become 0 when there is a scaling policy? Understand that question. You are setting desired as 2. It may create 2 servers and you define minimum as 0. There is a scaling policy, scale in, scale out, both policies are there. When there is no load, will it continue to maintain 2 servers by that scaling policy, by that auto scaling group? No, it will become 0. If it is becoming 0, that is of no use, right? So minimum you need to maintain some servers. Somehow I have closed this one. Let me create again quickly. I have closed the tab by mistake. Is everyone clear? What is that minimum? What is the desired? I close the tab. Let me click select. So in this network, in these subnets, click on next. Let me integrate with existing load balancer. Somehow I have closed that one. That's why. Now let me define the minimum to desired. You can say 3 or 5 or 4. So it will create 4 servers. If I say desired 4, it will create 4 servers right away. But if you don't have a scaling policies, will it increase or decrease? If you say desired, you can say 4 now, or desired you can say 3. It will create 3 servers or 4 servers now. But if there is no scaling, scale out policies, is the desired will be increased and decreased automatically? No. So when I'm initially creating, I'm saying desired as 2, and I am creating a policies, target tracking policy. So based on the metrics, based on the CPU utilization, based on the network utilization, based on the load balancer request counts per target also I can select. Just for demonstration purpose, I am taking 20%, average CPU utilization 20%. But in real time, you can set threshold value as 80 or 85. For now, I am just taking 20% to demonstrate this scaling. Now with this, I am creating a auto scaling group. I am not sending any notifications. I am not sending any notifications. Let me give the tags. Tags I am giving something like this Maven, that application ASG servers. Now the moment I click on create auto scaling group, there will be two servers created for that auto scaling group. There will be two servers because decide is 2, currently 0. Two servers will be automatically created. So who is creating these two servers? I have not done manually. Let me refresh here. Let me refresh here. Let me keep on refreshing here. I can see two servers will be automatically created. I can see two servers will be automatically created. I am not doing anything manually. So who is creating these two servers? You can see this one and this one. Auto scaling group. But how come auto scaling knows that it has to create a T2.micro and it has to use this AMI, whatever AMI it was used? Like how come auto scaling knows it has to use that AMI, it has to use that instance type, it has to use this security group, it has to use this security group, and it has to have this user data. This user data also here you can see in the detail section. In the detail section you can see that user data also. Maybe if it is not shown here, you can see here, you can see that user data here. Go to actions, go to actions, instance settings, instance settings. You can see this user data here. So as of now still it is not ready, that's why we don't see that option, any option. So let's wait for some time. Select this instance, go to actions, you see instance settings. You can see that user data, who added this user data automatically, everything where we have defined all this information, instance type, AMI, security group, storage, user data, in the launch template, in the launch template. So using launch template, it is creating EC2 instances. So is everyone clear who is creating these two servers, this one and this one, automatically? Now, since we integrated these servers with the target group load balancer, if you can see, is these two servers is automatically registered into this target group. You can see these two. Can you see this one and this one? Whatever I have highlighted, is it automatically registered into the target group? And again, our application is there, Tomcat is there. Do you see that is healthy? Yes. And since we integrated with load balancer, when any end customer is accessing that application via this load balancer, does request goes to that server which is created and managed by auto scaling group, because that is part of the target group. You can see I am getting a response from this server 10.0.86. That server is actually created and managed by auto scaling. That server is actually created by and managed by auto scaling. Is the load balancer is forwarding the request to that servers where those servers are registered into the target group. You can see this server is giving the response for me, which means since we integrated with load balancer, Is load balancer is forwarding the request to this server created and managed by auto scaling because it is part of the target group? Yes. Now, if anything goes wrong with these servers, scaling I will demonstrate later, even though these two servers has some issue, if anything goes wrong with this server, does this server will be replaced with another server? If I intentionally stop also, maybe something went wrong with that application, or network failure, server failure, or application failure, is that server will be terminated and another server will be created automatically? Yes, because these instances are managed by auto scaling group. If you go to that auto scaling group, if you go to that auto scaling group, this auto scaling group, you can see it has created two servers because desired is to currently 0. It has created two servers in the auto scaling group activity. I can see, and if you see instance management, you can see these two instances are managed by that auto scaling. Now let me intentionally stop the server. Which is created and managed by auto scaling. So even though I'm intentionally stopping this server, let me stop only one server. I'm intentionally stopping one of the server, this server. Does auto scaling can detect this, and does auto scaling will terminate this server? Whatever server I have stopped as of now, is that server will be terminated and another server will be created automatically? This server which I am getting stopped, yes. But since we are using load balancing also, is load balancer will stop sending the request to this server as per the ELB health checks, and there is one more server, I may get a response from another server. You can see I'm getting a response from another server like this. Now load balancing is doing its job. Load balancing is identifying that instance is unhealthy and it is stopped sending the request to that server. It stopped sending the request to this server, and auto scaling will what it do? It will terminate this server and it will create another server. You can see here, I no need to do anything. If you see, let me remove that filter. If you see, is it started creating one more server? You can see this is coming up pending state. Now after some time it will be shown in a running state. After some time this will be shown in a running state. Who is creating this server which is now into running state? It came. Who created this server? Auto scaling group only. And whatever server I have intentionally stopped, is that server will be terminated once this server came to service. Once this server is fully ready, is this stopped server will be terminated? Yes, this will be automatically terminated by auto scaling. So who is managing the life cycle of our EC2 instances? If we are using auto scaling group, AWS auto scaling group is managing the life cycle. So is everyone clear? What is auto scaling group? How important it is auto scaling group to achieve availability, fault tolerance? Now we integrated this auto scaling group with load balancer. Is this target, is this server again automatically registered into the target group instead of you manually register whatever is created by that auto scaling group? Yes, you can see again this new server is there. But other server will be terminated in some time. Other server is terminated in that some time. Whatever I have intentionally stopped, right? This server will be terminated. You no need to terminate. Auto scaling group only will terminate. So at any point of time, do I have some minimum servers available to handle my traffic now? Yes. Now scaling. I already have a scaling policies created. In this auto scaling group. I created a target tracking policy. Now if average utilization goes at 20% on whatever targets you have, let's say currently you have two servers, so average of two servers it will take. Currently you have two servers, so average of 2 servers, 20% goes above, then will it trigger the event to update the desired capacity? Yes. So we created a target tracking policy. Internally, it has created some CloudWatch alarms. If you go to CloudWatch, you can see some alarms. You can see some alarms. You can see some alarms. Let me go to all alarms. There are two alarms. There are two alarms got created. If you see, if CPU utilization goes greater than 20%, if CPU utilization greater than 20% for 3 data points within 3 minutes, 3 data points within 3 minutes in the sense continuously 3 times within a 3 minutes, if the average CPU utilization is greater than 20 in that targets, this alarm will trigger an event to the auto scaling group to update the desired capacity. If this condition is satisfied and if this alarm triggered an event to update the desired capacity, does the desired capacity becomes 3 or 4 when this condition satisfied? Yes. If the desired capacity becomes 3, does auto scaling will match the desired servers with current servers? Currently only 2 is there. Now is it going to match with the desired capacity to create one more server? Yes. And this is scale out policy. This is scale out policy. Similarly, you have a scale in policy. Similarly, you have a scale in. Even though it has increased the servers, if there is no load like this, let's say if CPU utilization is less than 18% for 15 data points within 15 minutes, considerably less load. Continuously, there is no load for 15 minutes, 15 data points within 15 minutes. If the CPU utilization is less, this scale in policy will be triggered. Again, it will reduce the desired capacity. But will it make the desired less than minimum? No, it will not make less than minimum. But as I told, if you guys set minimum 0, can the desired also become 0? If this policy is there and there is no load, will it make minimum also 0 like that? 0 servers? This policy, if you set minimum as 0, yes. Understood, Vijay Lakshmi? Now, data points in the sense how many times? Data points in the sense how many times? 3 data points within 3 minutes. Within 3 minutes, 3 times. Within 3 minutes, 3 times, it should be greater than 20. Because if you take CPU utilization, there will be a spike, right? I hope you can understand what do you mean by CPU spike. Sometimes, right? It may go 80%, it may go 90%, but within some seconds it will come down the CPU utilization. But at the spikes I don't want to take the scaling. I don't want that scaling should happen. So that's why AWS has these concepts. 3 times within 3 minutes. If it is greater than 20, then only this alarm will trigger. It will not trigger the scaling for normal spikes, CPU spikes. Clear? And again, for scaling in, for decreasing the desired, it is continuously 15 times less than 18%, 15 times within 15 minutes, so that it will consider there is no load and it is going to trigger this alarm to reduce the desired servers. So internally, the scaling policies are used, these CloudWatch metrics, CloudWatch alarms. If you see as of now, you can see this is the borderline. I just set 20% for demonstration. So as of now, it is under control only, right? So this point of time, it was just 5%. Now it is just 3%. So am I going to get a third server, fourth server? No, no. But let me programmatically put the load. Let me programmatically put the load. I want to show that demo. I want to show that demo. Even though this is not a AWS course, but whatever services I am explaining to get started with Terraform, let me explain in detail again. So as of now, you can see that auto scaling group, the desired capacity is 2. The desired capacity is 2, and currently 2 instances are there. Now there is a scaling policies. There is a scaling policies. Now let me programmatically put the load in one of the server. Let me SSH to one of the server via public server, via kind of jump box. I will SSH to this private server. So I am already into public server. From that public server, I will SSH to one of the server. Guys, before I demonstrate this one, let me ask you one thing. If something goes wrong with these servers, whatever I created manually, is auto scaling is going to create another servers, these two, which is not created and managed by auto scaling, right? So if I terminate also, nothing will happen. If I terminate also, nothing will happen, these two servers, because these are created by us manually. But if something goes wrong with these servers created and managed by auto scaling, it is going to recreate. Okay. Now let me demonstrate the scaling. Let me demonstrate the scaling. Let me SSH to the one of the server which is created and managed by auto scaling. I will programmatically put the load. I will use some benchmarking tools. I will use some benchmarking tools and programmatically put the load, because I don't have a lot of customers. I can't ask everyone to attend the sessions and everyone to hit this URL at the same time like that. So I will programmatically put the load using some benchmarking software. Let me install that benchmarking software called the CG. I'm using one benchmarking software, performance benchmarking software, this one. I will install this software and I'll programmatically put the load, kind of a performance testing I am going to put. So it is an open source benchmarking tool. I can programmatically put the load using this one. So let me install this to demonstrate that load, right? Scaling. So I'm installing one software directly in that server. This server is created and managed by auto scaling. And using that tool, I'll put programmatically load like this. But let me install that software. Guys, it is going to take average of the current instances. Let me tell you one thing. What do you mean by average, right? Let's consider in one server, you have 10% load. In another server, you have a 30% utilization. In one server, currently there are two servers, right? In one of the auto scaling group server, 10% utilization is there. In another server, 30% is there. Do you think scaling will happen even though I have given utilization like this? CPU utilization greater than 20? No, because it is going to take average of current instances. Currently there are two instances, and in one server 10, in another server let's say 25. Let's say 25, just to understand this one. In one server 10, another server 25. So what is the average? Currently two servers, so 35 by 2, is it above 20? No, 17.5. But even though in one server you have something like this, in another server, let's say in one server there is a load balancer also, right? It is distributing the load. Let's say if this is the case, right? One server 19, another server 24. So currently two servers. It is like 43 by 22. Sorry, 43 by 2. So it is how much? 21.5. So this time the scaling will happen because of this threshold value. Yes. So that is how it will take. So let me install that software to put the load. Okay. Let me install that software to put the load. Let me download the tar file, that CG software tar file. Guys, whatever I am explaining here, this is nothing to do with Terraform, okay? I'm just explaining some applications. Terraform is just used to create a resources, your AWS resources. Using Terraform, can I create a EC2 instances directly? Yes. Can I create a VPC and its components? Yes. Can I create a auto scaling group, launch configurations? Yes. Can I create a EKS clusters? Yes. But whatever I am explaining today, this is nothing to do with Terraform. I'm just taking one application and demonstrating AWS concepts so that you can understand something in AWS and how application works also. But using Terraform, you can't put all these loads, all these things. Terraform, you can just use for creating a AWS resources. Instead of manually creating AWS resources, you can create AWS resources like EC2, ELB, auto scaling groups, VPCs, load balancers, EKS clusters, RDS instances, all those things also Terraform. Okay. Now let me see if I have the software installed. Yes. Now I am programmatically putting the load. Since I am already into this server where my application is already running and I am also into this server only, if I do something like localhost also, you can see that response because I am already into that server. The server created and managed by auto scaling group. I SSS to that server. I SSS to the server. So I am just using localhost also. It will work because I am already SSS into that server. It will work. You are getting a 200 response like this. So using that CG software, I am putting a load. This what do you mean by -c, right? It is like concurrently 200 requests, concurrently 200 people, continuously 7 minutes, -t. All these are options of this performance benchmarking tool. So -c, which means concurrently 200 requests, -t 7 minutes, continuously 7 minutes. The request will go to this endpoint. So I am already into that server. So I am executing this command on this server. So load will be increased, right? So continuously 7 minutes, there will be a load on that application now. And if you come back to your CloudWatch also, if you come back to your CloudWatch also now, after some time, you can see the spike here. You can see the spike here. So it will go above the borderline. At instance level also, you can check, guys. At instance level also, you can check. There is a monitoring. There is a monitoring at the instance level also, but by default detailed monitoring is not enabled. Detailed monitoring will give the data at 1 minute interval, but for free they are giving data at 5 minute interval. Now in this server only I have put the load. Now you can see here is the CPU utilization is started going above. Now as of now, at currently it is like 30%, but only in one server I have put the load. So if it is goes above 40, then only average comes 20, right? I have put the load in this server. If it goes above 40, then only average comes 20. So let's see if it goes above 40. Now there is a lot of load happening on this server. Using that performance benchmarking tool, I am making some kind of a performance testing, load testing. This is nothing to do with Terraform, okay? Just I'm explaining some application, how to use those applications in AWS resources. I'm discussing AWS features, not Terraform features as of now. Now, if you see, now if it goes above that number, right, 40% above, only in one server I put the load. Directly in that server only I put the load. Here you don't see any load. You don't see any load because I have put directly on that server using local host only. So this server has some CPU utilization because I am putting the load on this server application. Now if it goes above 40, then average becomes 20. If this goes above 40, then average becomes 20. Let's hope for that If it goes above 40, then scaling will happen. Now let me keep on refreshing the CloudWatch also. Let me keep on refreshing the CloudWatch also. As of now, average is something like this 15 only. Average is 15. If it goes above this border line, then this alarm will trigger an event to auto scaling. Let's hope for it. Wait for some time and let's see. If it goes above 40, then average becomes 20, but still it is there 30 only. That's why average is coming as 15 here. Let's wait for some time. Maybe I should have given, for testing purpose, I should have given that threshold value as 15 so that it would have practically possible to show that. But let's see. We'll wait for some more time. No, it is just 30% only. So average is just coming 15. Maybe let's see. Still this load is going on. So I am programmatically putting the load, but in real time, if these applications are accessed by multiple end customers via that load balancer also, does load will happen in that servers where my application is actually running? The load balancer is routing that request to that servers only, right? In real time, when multiple end customers are accessing this application, load will happen. If this load is happening as per that my policies, as per my policies, those additional servers will be created, and is that additional servers will be added to the load balancer. Again, is load balancer is going to distribute the load to that new server so that you have more servers available whenever there is a load. So is everyone clear the logic or the concept behind this ELB and auto scaling? Let's see if I will get the third server. If this condition now, yeah, now we cross this one, right? We crossed this one, right? Now you can see what is the average as of now. Now here average is 29, 30. My border value is 20, currently it is 30. So is it going to trigger an event? Now let me refresh here also. You can see it goes, it is as of now it is almost 60. So that's why average come 30. Now I no need to do anything. If you go to your auto scaling group, if you check, if you go to your auto scaling group, do you see automatically this desired became 4 because there is a lot of load, and to match this desired number currently is additional 2 servers got created, is additional 2 servers got created here. I didn't created manually. If you see who is creating this server which is initializing, and also one more server, this is also initializing. Current to the 2 servers, additional 2 servers are getting added. So is auto scaling is creating these servers to match the desired state. Yes. Now auto scaling has triggered this alarm. Now this is in firing state. Alarm fired because this condition is satisfied. So this CloudWatch alarm internally update the desired state. If you go to auto scaling activity, if you go to auto scaling activity, so this CloudWatch has triggered alarm here. If you go to this auto scaling activity, you can see So this alarm target tracking policy, it has updated the desired capacity from 2 to 4. That policy has updated the desired capacity from 2 to 4. Since it has updated the desired capacity from 2 to 4, is it launching the instances to match the gap between that desired and current? It has created 2 more instances, right? Is everyone clear? Does any data or request can last by at the time of creating new servers? Why it will last the data? Because it's a stateless application, right? It's a stateless application. You are not storing any state, any data in these servers. This is a stateless application. You are going to use some kind of a databases where you are going to actually maintain the state, and your load balancer will not send the request to these servers unless until it becomes healthy. Does load balancer will send the request immediately to this instance unless until that instance becomes healthy, that application become healthy? No. Okay. Now if there is no load again, will it make the desired, will it make the desired as 0 again? Sorry, desired as 2, something like that? Yes. Now my load testing is completed. My load testing is completed. So since I have used some tool as a performance benchmarking tool, it is giving the report. It is giving the report. So within this 7 minutes, how many hits has happened to that application and how many request has successfully completed. So my application availability is 100%. 100% in the sense all these requests are successful requests. Not even a single request failed. So these many requests, almost 2.5 lakh requests went to that application in this time. This many 100% availability, and this much data is transferred. You can see throughput, concurrency, successful transaction, failed transaction, longest transaction like this. Now if I don't put the load, if I don't put the load, right, again automatically this becomes 2. Is everyone clear what is auto scaling group, how it works? Guys, once your practice is done, once your practice is done, if you want to stop this application, if you just stop the servers, if you just stop the servers, do you think this will be stopped? Or if you terminate also, do you think this will be terminated, these servers? No. So if once your practice is done, what you need to do if you want to delete these servers permanently? You go and delete, you go and delete auto scaling group, or you go and delete auto scaling group, or you make desired 0 current 0, I mean to say minimum 0, desired also 0. You go and update desired also 0 and minimum also 0. Make desired 0, minimum also 0. Auto scaling group will be there but no servers. Otherwise you delete the auto scaling group. So you go to auto scaling group, delete the auto scaling group. So that's it for today, guys. That's it for today. So try to practice all these things. I mean to say, at least create resources in cloud manually. You will understand the pain. You will understand the pain when you are creating your VPC manually, when you are creating EC2 manually like that, what and all things you are going to provide as an input, so that when you learn Terraform, it becomes easy. So if you see, I'll show you, there is some Terraform has worked based on the provider's concept. There is AWS provider. This AWS provider has the resources. The way I have shown yesterday, right? Load balancer. You can create auto scaling group also. You can create auto scaling group also using Terraform. You can see, right? Auto scaling group, right? And using AWS Terraform resource, you can create, you can define launch configuration. You can define auto scaling group. You can say something like this: resource AWS auto scaling group, your group name, minimum size, maximum size, health check grace period, health check type, desired capacity, which launch configuration. So did we define all these things manually when we created auto scaling group today? Name of the auto scaling group, minimum size, maximum size, desired size, and which launch configuration has to use, under which availability, under which subnets it has to be created. Did I done all these things manually today to create one auto scaling group? Yes. Now, if I have something like this in my Terraform script, if I have something like this in my Terraform script, if I apply the Terraform script, does Terraform is going to create auto scaling group with this name, with this group size, using this launch template? That is what infrastructure as a code. That is what infrastructure as a code. But when you directly do this, you may have a lot of doubts. Sir, what is this min size? What is this max size? What do you mean by this health check? That is nothing to do with Terraform. What you are giving here, you are giving input in the Terraform, so the Terraform will internally make a API calls only using this input to create a resources in AWS. So that's why I told first learn what is cloud, what is AWS, what do you mean by EC2, VPC. Without knowing all these things, if you by heart this one also, will you able to understand? You may able to create, but will you able to understand what you are doing here? No. Now if you know auto scaling group, this is nothing, right? You just need to define your code like this, that's it. Try to manually play around with these AWS resources so that you can easily learn Terraform and all those things. So that's it for today, guys. That's it for today. Once your practice is done, terminate your auto scaling group, or maybe just select this, delete the auto scaling group, and delete this auto scaling group. And you need to delete step by step. Like again, you can't delete in proper order. You need to delete. So load balancer, without deleting a load balancer, you can't delete target group. So first you need to delete the load balancer, then you need to delete the target group. But if I have a Terraform, I can execute simply Terraform destroy. So whatever resources has been created using Terraform will destroy all those resources instead of you manually delete. Sir, is Terraform and CDK functionality both are same? Guys, Terraform is developed in one programmatic language called Go. So that Go programmatic language is the Terraform core. Terraform core is developed on Go programmatic language, and there are providers. That providers are nothing but client libraries of AWS. So the Terraform will internally make a API calls. It's a API calls. You no need to write any code. You are using Terraform in a declarative way. So the Terraform core using that provider, it will make the API calls. You no need to write any code. The provider is the code. The provider Terraform core using provider, it will make the API calls to create the cloud resources. That we will discuss when I start Terraform. Okay, not now. But since you are asking that question, I am explaining. You no need to write any code. The provider is a code. The provider, the Terraform will invoke. The Terraform will work with providers. Providers will make the necessary API calls to the cloud to create these resources internally. Thank you, guys. That's it for today. I'll continue tomorrow. So tomorrow we are going to start with one more service, important service, that is RDS. RDS, Relational Database as a Service. Instead of you set up and manage the database, there is a service for database also, that RDS. We will discuss what is RDS, how to create RDS manually. Okay. Thank you, guys. We'll continue tomorrow.